Hi guys, I'm Praveen Shukla. So I'm making video here about sets. Okay, it's about class for ninth. So I'm making here for the set. So now group of object or element, we can say that is what set. So 5, 10, 15, 25, 30. This is the what example of what set of multiple of 5 below 35. Or we can say that here A is equals to what? This is the A is a group of set, means A is a any set here you have to given. So set of multiple of 5. So A is equal to 5, 10, 15, the dot. It means what? This is a multiple of 5. Okay. So you know it. Set how many types method contains only two, that is roster method or tabular form. This is having two types. Okay, and then set builder form or rule method or description method. This is also what types of set. Now what is the meaning of the roster method or tabular method? So now listen, I'm just giving example and each and everything you're going to be clear over here. So A is equal to, I'm written here set of prime number 30 to 50. So 30 to 50 prime number you have to write in the roster method. So we can write here A is equals to 31, 37, 41, 43, 47. These all are the what set of prime number. So that's why in the roster method we can write here what 30 to 50 prime number. So set we have to make, so 31, 37, 41, 43, 47. Okay, if I am giving example here for the what, let B be the set of odd number greater than 100. So we can write here 101, because first of all you try to understand what is the meaning of the odd number. So odd number is what? Those are not making pair. So that is 101, 103, 105, 107, 109 and dot, because it's going to be infinite. So that's why. And after that, one more example, let C be the set of vowel. Vowel means what? Like A, E, I, O, U. You know it, that is 5 only. Okay, if you don't know, then you have to try to understand about that. And then after set builder form, now listen, what is meaning of the set builder form? So set builder form or rule method or description method, that is called what? Such that x, such that x. So please try to understand this as such that, and this such that also called like this way. If we put two dots like ratio in form, that is also called such that. Okay, so if I have written here 8, 10, 12, 14, 16, 18, so this is what x says that x even number 8 less equals to x and less equals to 18. So it means till 18, because equals to sign is given, so equals to sign representing that over here, till 18 you have to be take, and start from where 8, because 8 is less equals to given na? So that's why. Okay, and then we can write here 16, 25, 36, 40, 49, 64, 81, 100. So this is what? This is the set of B. So x says that x is equals to n square, because n square is given, 4 square is 16, 5 square is 25 and 6 square is 36. So 4 less equals to x and less equals to 10. So that's why we can write like this way. Got it? This is a set. Okay, this is the very important thing, set of number. So natural number, it is denoted by n and is equals to 1, 2, 3, 4 dot, because you know it, natural number is always start from 1 to infinite. So that's why we have written here natural number is denoted by n also, capital N. And whole number for W, and it is from 0 to infinite, so 0, 1, 2, 3, 4 dot. And then after integer is denoted by z or I sometimes also. Okay, so it's equals to, it is containing negative and positive as well as 0 also, both the numbers. Okay, and then after rational number, you know it, rational number is denoted by q, and it is always in the form of p upon q, where q not equals to 0. So p belongs to what? P, it is called belongs to, p belongs to z and q belongs to z, but you have to remember q not be equals to 0. So that is called what? Rational number. Got it? And then next is what? Finite set. What is finite set? So you know it about the finite set. So the process of the counting of elements surely. So it is countable number of element, that is called what? Finite set. So example, we can say set of all the prime numbers less than 10. So just like 2, 3, 5, 7. So this is called what? Countable. So this is called finite set also. So set of letter we can write here. So A, B, C, D to where? To till Z. So that is called what? Finite set. Yes. Now another is what is infinite set. So infinite set means what? uncountable number of a distinct element. Example what? Like set of all the natural number. So natural number if you write, then it is counting from 1 to infinite. So 1 2 3 4 5 dot dot dot. So it is uncountable. Got it? So it is what? Infinite set. And after that, set of all the person on earth, this is also what? It is a infinite set. Clear? And then after what is mean of the cardinal number? This is very important topic in this, so please try to understand what is cardinal number of a finite set. And you have to remember this, the cardinal number we have to always find in the finite set only. So it is applicable only on the finite set because it's countable, so that's why. Example, we can write here a is equals to 1 2 3 4 5 6 7 till 7 I have written. So we can write here what? Cardinal number is what? Number of a is equals to what? Just you have to count it. So 1 to 7, so there is 7 numbers, so we can write here 7. Clear? Next topic is what? Empty set. So what is empty set? You have to know that a set consists no element, so that is called what? Empty set or null set also. Okay, and it is denoted by phi. This is called what? Phi. Okay, and phi is equals to, you have to make like this, so it is also called what? Empty set. Clear? So number of a, if you want to find out number of a means cardinal number of this, so we get what? 0. Okay, so in empty set cardinal number will be 0. Clear? And after that what? Non-empty set. Non-empty set means what? At least one element consists there will be, so we can say that that is non-empty set. And single tone set means what? Those having single element, that is called what? Single tone set. So number of a is equals to what? 1. So number of a is saying that what? This is the cardinal number of a, that is 1. Clear? So that is called what? Single tone set. Clear? So now next, that is equal set. What is equal set? So two sets a and b are said to be equal written as a is equals to b if every element of a is in b and every element of b is in a. So we can say that that is what? Equal set. Like example I am just giving you, let a is equals to x, as that x belongs to whole number and x not belongs to natural number. It means what? B is equals to x, as that x belongs to integer and x is neither positive nor negative. So now we can be changed in the form of what? Just like a is equals to 0 because there is given condition, that is a because a x belongs to whole number, x not belongs to natural number, so only one number is going to be over here, so that is 0. And here x is integer but x is what? Neither positive nor negative, so neither positive nor negative, that is 0. So a also containing 0 and b also containing 0, so we can say that what? A is equal to b. So now this is called what? Equal set. Now next is what? Equivalent set. What is the equivalent set? So two finite set a and b are said to be equivalent, written as a equivalent to b if number of a is equal to number of b, that is they have same number of elements. Okay, so example, like we can say here a is equals to a, e, I, o, u and b is equals to 1 2 3 4 5. So equal number of element it is given, so that's why we can say that number of a is equals to 5 and number of b is equal to 5. So we can say that number of a is equal to number of b. So that is called what? Equivalent set. Clear? Now another topic is subset. So if a and b are two sets given in such a way that every element of a is in b and a is a subset of b. So now we can say the subset is denoted by what? Like this sign. So a subset of b. So now we can say that a is a subset of b. We can read like this. Okay, if that is not in b, so we can say that a is not a subset of b and a is not a subset of b. We can read like this. Okay, clear? And I'm just giving example. Let a is equals to x, as that x is a prime number, 3 less than x and less than 15, and b is given what? X, as that x is odd but what? X belongs to natural number, 3 less than x and less than 15. So now we have to make the what? A in set builder form. So 5 7 11 13 will come because question is given prime number. So b is equals to given 5 7 9 11 13. So now a subset of b. Why? Because all the elements of a is in b. So we can say that what? This is called what? Subset. And now one more thing is that is superset. What is superset? Superset sign is this. It means what? B is a superset of a. Clear? And next thing is what? Yes, empty set is a subset of every set. This is the property of it. We can say that if A is subset of B and B is subset of A, so we can say that A is equal to B. And now if A contains number of n element, then there are 2 power n subset of okay, so we can say that A. So now we can say that 2 power 4, 2 power n is given the formula. So 2 power 4 means we can say that if there is given number of element will be 4, so we can write here 2 power 4 is equal to 16. So this that 16 number you can be find out as a subset. Okay, next is the power set. Power set means the set of all the possible subset of A of a set A is called the power set of A, and it is denoted by power A, the PA, that is called power of power set. And if A contains an element, then PA is equals to what? Contains 2 power n sets. Now we can say that A is equals to 2 comma 3. So here n is equal to 2. So we can say that 2 power n means 2 power 2 is equals to 4. So now 4 is a what? 4 subset of A. Clear? Yes. And then after what is possible subset? So if A1 is given 5 and A2 given 2 and A3, these all are the what given. This is a possible subset of this one, 2 power 2 1, that is 4. So there is the possible subset of 4 subset is given. Okay, and what is proper subset? So let A be a any set and B be a non-empty set, then A is called what? Proper subset of B. So A is called what? A is a proper subset of B. We read like this way. There is given A is a subset of B and A not equals to B, so we can say that A is a proper subset B. Okay, if I will give example, so A is equal to 2 3 and B is equal to 2 3 5, so A is subset of B but A not equals to B. Okay, so A is a what? Proper subset of B. Okay, and 5 has no proper subset, so please you have to remember this thing. And after that what? This is given what? A is a subset of A is a subset of A, and B is subset of B, and A is subset of B, and B subset of A. So we can say that A is equal to B, and in this condition what? A not equals to B. So number of proper subset of set, like 2 power, if you want to find out number of proper subset of a set, so 2 power n minus 1 is the formula. So proper subset is 2 power n. So we can write here A is equals to 3 4 5 6, so n is equal to 4, so 2 power n is means what? 4. So 2 power n means 2 power 4 minus 1 is equals to 16 minus 1, then we can write here about 15. This is what number of proper subset of set. And what is the universal set? This is very important thing. This is denoted by U or sometimes like this sign. So A is equals to, if written 1 2 3 4 and B is written 2 3 5 7, so C is equals to written 2 4 6 8. So universal we can write here 1 2 3 till to 1 to लेकर कहाँ तक 8 तक. So 1 2 3 4 5 6 7 8. Clear? If anyone is repeating, so you have to write down namely single time. Clear? Operation on sets. So union of sets. So union, you know it. The union of two set A and B is denoted by A union B. So A union B we read like this way. So example, just like A I am written here 2 3 4 5 and B is written 2 4 6 8. So A union B we can write here what? 2 2 is getting equal, means same is same element. So we can write here 2 3 4 4 same, but one time we have to write down 5 one time, so 5 6 and then 8. Okay, and if there is given C is equals to 2 4 6 8 10 12 and dot 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 dot, and D is given 3 6 9 12 15 18, so we can write like this way, whatever is getting over here. So you have to write down C union D is equal to 2 3 4 6 8 dot 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 like this. Okay, there is some property of union set, so that is commutative, means A union B is equals to B union A, that is commutative. And associative means what? If A union B and union C, so we can write here what is equal to A union B union C. Clear? And if it is written what? A subset of A union B, so we can write here B subset of A union B. Clear? Case is just like given, just A subset of B and A union B is equal to B. So case number 2 is given A is a subset of universal, so A union universal is equals to universal will come. Okay, and then after there is given if if there is given A union phi, means empty set is equal to A will come. And now here intersection of set. So the intersection of two sets A and B denoted by what? A intersection B. So we read as A intersection B. So now A is equals to 2, 3, 5, 7, 9, 11, 13, and B is given 5, 9, 13, 17, 21. So here A intersection B is like what? HCF. So we can write here what? 5, 9, 13. Those are making common over here. That is what? That will be a intersection B. Clear? And what is a disjoint set? So two set A and B are said to be disjoint if they have no element common. So we can say that A intersection B is equals to what? 5, means empty. So A is equal to given 2, 4, 6, 8 and B is given 1, 3, 5, 7. So we can write here A in intersection B is equal to not getting any common one. So that's why we can say that what? That is 5. Okay. And then after, what is intersecting? Please you have to remember intersecting set. So two sets are said to be intersecting or overlapping or joint sets if they have at least one element in common. So that is called what? A intersection B not equals to 5, means any one will be the common in it. So A is equal to 5, 7, 9, 11 and B is equals to what? 9, 11, 13. So we can write here A intersection B is equals to 9, 11, and here in number of A intersection B is equals to what? 2, because that is cardinal number. Clear? And there's properties of intersection of sets. That is commutative, means A intersection B is equals to B intersection A, and associative property like A intersection B intersection C. So it's equals to, we can write here A intersection B intersection C. If there is given A subset of B and A intersection B is equal to A, and if there is given A intersection A subset of universal, so we can write here A intersection universal is equals to A, because it will be make common in this. So A intersection phi, so it will become phi. Clear? Yes. And then what is the difference of set? So for any two set A and B, the difference A minus B. Okay, so A is given 1, 2, 3, 4, 5, 6 and B is given 2, 3, 4, 5. So we can write here A minus B. So there will be only 1 and 6 will left, because otherwise will be minus it. So now we can write here A minus B not equal to B minus A. Okay, so 1 minus, I'm just giving an example, 1 minus 2 is equals to 2 minus 1. It happen or not? So it will be never will happen equal. Okay, now what is the complement of set? So A dash, we say that what? A complement means A naught. So just like universal is given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So A is equals to what? 5, 6, 7, 8, 9. So if you want to write here what? A complement means A naught, जो A में नहीं है. So 1, 2, 3, 4 and 10. Okay, that's called A complement. Clear or not? And then after, what is the important rule sum there is, just like phi not given means A phi complement. So that is called what? Universal. If there I am written what? A union A naught is equals to phi, sorry, that is the universal, and universal complement is equals to phi, and A intersection A naught is equals to phi. So according to De Morgan law, we can say that A union B complement is equals to A complement intersection B complement. And now listen here, union if given, then intersection, and if they are given intersection, then that will become what? Union. So now we can say that here what? A union B complement, so is equals to A. The same thing I am written over here, so please try to understand. Okay, thank you, bye, Jai.